Teacher Yandu, let's get started.
Well, good morning.
Good morning.
Kaki. Enkumbi tekijja kuba gumu bbiri.
Matovi Simon.
Enkumbi si kyekwaso.
Simon, morning. Is Simon with us?
I've just muted Simon because of the noise, allowing you to start.
Okay. Well, I want to welcome you. I hope you're getting me.
Yes.
Yeah, I want to welcome you for this online lesson that is sponsored by Yaaka Digital Network. I am by the names called Yandu Amos. I am a learning facilitator with Yaaka Digital Network. Just a moment, allow me to try to share the screen a bit. I have some connection. Well,
recording in progress.
Well, let me share my screen. I hope you're getting my screen. I mean, you're seeing my screen. Are you seeing my screen? That's where we're starting from. We are actually going to learn about a topic in mechanics that is which is dimensions. Allow me to take back. Sorry about that. I have issues with the network here. I'm trying to. So I think there we go.
Network.
Teacher Yandu, is there a problem?
Hello.
Hello.
Are you getting me?
Yes.
I hope my audio is not breaking.
Yeah, I'm getting.
Okay, thank you. I think I had issues of network. Now I think I've been sorted out. So I'm saying we are looking at the topic of dimensions, which is from mechanics. Under this topic, we shall need to first understand the fundamental quantities, which are actually the physical quantities that cannot be expressed in terms of other quantities using any mathematical equation. So by the concept of fundamental dimension, we are actually trying to informally say here that it is a way of trying to, in fact, dimensions is informally defined as the minimum number of coordinates needed to specify any point within physical quantities.
Excuse me, Teacher Yandu.
Yes, please.
Can you please remove sound in the other computer, the one you called DOS? Minimize it to 0. It is bringing the echo.
Network.
Is that better now? Hello.
Yeah. Yes, I'm getting it.
Okay.
It's now okay.
Yeah, let me just bring back. Try to connect back and share my screen. I'm trying to connect back, please. Yes. I think there we go. I was, I think, trying to explain about where the concept of dimensions comes in from. I did say that dimensions is defined as a number of coordinates that is any point within are actually derived. They are used in mechanics as they are derived from the fundamental quantities. These fundamental quantities are the ones which cannot be expressed in terms of other quantities. When you were just introduced to physics in Senior 1, you did learn about the concept of fundamental quantities and derived quantities, isn't it?
Yes.
Yeah, and then there you are able to learn that some of these examples of the fundamental quantities are, we have mass, length, time. Can you mention some of the fundamental quantities that you learned about that we have not actually included in my slide here that you still remember apart from this story? Do you remember one? Do you remember anyone apart from the ones we have here, mass, length, and time? Cups. Cups. Are you there? So now these fundamental quantities, some of them are, we have temperature, we have electric current, which are also some of the fundamental quantities. Now, these fundamental quantities, which are sometimes also called the basic physical quantities, we can express them in terms of their dimensions. The dimensions respectively for mass, length, and time are capital M, L, and T. So we can use these dimensions in order to now express other quantities in terms of them. Now, when we come to this table, I think we're seeing that table. Are we seeing that table? Where it is just a continuation of what was in the first slide, and then it summarizes actually what is in there. So we have the physical quantity of mass. The SI unit is kilogram. Kilogram starts with small k as a SI unit. So, and as a simple, the simple is small k as well. Then small g. Then we have length. The SI unit of length is meter. That's how it is written, and the simple is right in there. To continue with, we have time. The SI unit is seconds, small s. And then we have, as I did talk about, other fundamental quantities which we have added there, temperature and current. And their respective SI units are Kelvin and ampere. So the simples are also there. These Kelvin and ampere are units that have actually been derived from the names of the human beings behind the concept. So as a result, we see how the simples have been given for us there. They have to be written in the first, I mean the capital letter of the first, the capital letter of the names of the first letter. So that is what we can say as far as that is concerned. Next is we have the derived quantities. Now, these derived quantities are the ones which can now be expressed, I mean, which cannot be, I think I just missed it there. These are quantities which cannot be expressed in terms of the fundamental quantities. I mean, which can be expressed in terms of, which can be expressed in terms of the fundamental quantities. We have so many of these. There are so many examples of this quantities. The examples are we have area, we have volume, velocity. Those are the ones that we have given here, but otherwise we have other examples, even like pressure. We have the density, we have momentum, we have force, and so on and so on. So these quantities can be expressed in terms of fundamental quantities. Now, when we talk about their dimensions, how do we obtain the dimensions? So we have area. Area is simply obtained from the square of two lengths. That's why I was saying it is their length squared. It is length times length. So when you, for example, when you are getting the area of a rectangle would be obtained from by multiplying the length by width. So there we have two lengths, in which case the dimension becomes the first length multiplied by the second one, where you get L squared. Then when we move to volume, we have it is obtained from 3 dimensions. When you take a cube or a cuboid, there are 3 dimensions. These dimensions may be the length, the width, and the height for a cuboid. So all those ones are lengths. It gives us the dimension of length cubed, which is in simple given as L to power 3 there. Another example that we have there is velocity. Now, velocity is mathematically expressed as distance over time. Distance is actually length. Distance is length. And the dimension for distance comes in from the dimension of length, which is what? L. And then we have that of time, which is T. So we shall be having L divided by T. Now we do understand from indices, the concept of indices is that L divided by T, when we take the T up, it is going to be raised to power of what? -1. So that's why we now have there LT raised to power -1. So those are some of the examples of the derived quantities and their dimensions. You could now be asked to express some of the quantities or some many more of this in terms of many more of this derived quantities in terms of their dimensions. You can be asked to express the dimensions of so many derived quantities, but I want you to have this trial of expressing the dimensions of these following derived quantities of force, pressure, work, and momentum, and you'll be able to submit, I think, your trial in the group chat, maybe on the WhatsApp and then the WhatsApp group chat. So that's where we'll be able to have an interaction about. But otherwise, we have so many of this. We have so many of this. Derived quantities, which are obtained majorly from mass, length, and time. So you could be asked to express their dimensions. Now that is what I want you to do after here. And I really thank you for your attendance. Previously we had a lot of issues, especially with the network, but hope to make it better next engagement. For better services or to enjoy this kind of online services, you need to subscribe fully to Yaaka digital network. Though in the meantime, these are free lessons. Those who have not subscribed, you can subscribe to Yaaka Digital Network. I'm going to share for you the website, the website, or the link through that you can use to subscribe to. And then there are also some educative packages that you have from Educare. Similarly, I will also share a lot about that in the chat. Otherwise, I wish you the best. Thank you for attending.